Piecewise functions. Let's do this. So you're going to graph each piece at a time, starting with the graph of y equals 2 minus x. So this first one, y equals 2 minus x, is a line. The y-intercept is 2. The slope is -1. It's a negative 1x. So down 1 to the right 1. And then from there, you would draw a line. Now, I'm sure you're sitting there going like, wait, no, it's a piecewise. And I agree. You don't want the whole line, but draw the whole thing to begin with. I highly recommend using something you can erase with. Where does it end? Well, it ends before -1. So plug in an x equals -1, and you'll get 2 minus -1, which is 2 plus 1 is -1 comma 3. And again, you might go, but it's less than -1. Well, we're going to go right up to -1 comma 3 and have an open circle is what we're going to do there. And then we'll take that line, we'll erase just part of it. I have to erase the whole thing because, technology here. But that's the point where it starts, and then I would continue to draw the line out in this direction. That's the first piece, check. Next up, x squared is a parabola. Starts at the origin, and in that case, it's going to probably look something like this. But I don't want the whole parabola. I want it from -1 to 2. So I'd plug in a -1. -1 squared is 1. And it ends at 2, plug in a 2, and 2 squared is 4. So what I really want here, again, erase, is I want it to exist from -1 comma 1 with a closed circle, because it's equal to 2 comma 4 with an open circle, because it's just not equal to. And I would draw my parabola there. Lastly, 3. What's the graph of 3? Well, that's a horizontal line. But I want it starting when x is greater than 2. Now, you're not going to plot at 2.000001. You're going to plot at 2 comma 3, an open circle, and then continue that horizontal line. So notice what I did overall. Basically, I graphed the entire piece, found the point where it either starts, ends, or cuts off, and then kept the side that it exists. And I did that for each piece of this piecewise function.